All right, good evening, mathematicians. I hope you guys remember to turn your clocks forward 1 hour for daylight savings. Anyway, I'm going to walk you guys through lesson 3.2. It's titled Investing for the Future, and we're going to talk about those things we called growth rates. Okay, so your focus question for this lesson is, how are the growth factor and growth rate related for an exponential function? Okay, so go ahead and write that down. So the growth rate, well, this is just the percent increase in an exponential growth pattern. Last class we talked about our original populations being represented by 100%, right? Otherwise known as a growth factor of 1, right? So the growth rate at that point is just there isn't one, right? We're still at 100%. We're not growing very much. So for a good example of this, if I were to say that my population is growing 180% each year, that means that there's an 80% increase. And this value right here, and this value right here is what we call our growth rate. That is what we are growing by. That is what our function is growing by every year or every month or every minute, whatever our x value is. Okay, so we have given you guys some very important conversions here. Okay, so the first one is how to calculate the growth factor and growth rate. We talked about growth factor already. We talked about how to calculate it. You're going to take the population of 1 year and you're going to divide it by the population of the previous year. That is how you determine the growth factor. We've already talked about that. But now let's take a look at how we find the growth rate. So this says you're going to find the difference in population of 2 consecutive years. That means we're going to take the y values of 1 year and the previous year, and we're going to subtract the two. So I'm going to say that P is the previous year, and this is just any year. Oops. Let me write any year. So this is the y value at any year. In this case, we're talking about years, but it could be whatever. It could be months, it could be minutes, and so on and so forth, okay? So you find the difference of those two, you subtract them, and then you are going to divide by the population of the previous year. So let's take a look at an example. So if let's say that in year 3, I had 15 squirrels. And in the 4th year, I had 30 squirrels, right? So I'm going to say that this right here, this 30, this is going to be my P plus 1. And this 15 is going to be my P. So I need to find the difference in the population for those 2 years. So I'm going to do 30, which is P plus 1, minus 15, and then divide it by 15, which is my original value here. So 30 minus 15 is 15, and 15 divided by 15 is equal to 1. Change this into a percentage here. Whoops, hold on. 1.0 is the same thing as 100%. So I have a growth rate of 100%. That's all that means, okay? So if you take the population of 1 year, subtract the population of the previous year, and then divide by that same number, you will get your growth rate. Okay, we're going to walk through more examples here. Now, you guys will also have to convert between growth rate and growth factor. So we've given you that here as well. If you are given a growth rate, you're going to follow the top part here. You're going to change your percentage into a decimal, and you're going to add 1. If we give you a growth factor, you're going to follow the bottom over here to go to a growth rate. So if you're given a growth factor, you're going to change that growth factor into a percentage, and then subtract 100%. Okay, so let's take a look at an example. So when Sam was in 7th grade, his aunt gave him a stamp worth $2,500. Sam considered selling the stamp, but his aunt told him that if he saved it, it would increase in value. That's a pretty nice stamp. So Sam saved the stamp and its value increased by 6% each year for several years in a row. So we got 4 parts to the problem here. Now, before I let you guys work on this, so it says to make a table showing the value of the stamp each year for the 5 years after Sam's aunt gave it to him. We need to talk about some things. Well, this 6%, what does this 6% represent? Well, this represents our growth rate, not yet our growth factor. We know that in exponential functions, we need a growth factor, right? When we write an equation like this, a times b to the n power, this b right here is our growth factor. We need that. So we need to change this growth rate into a growth factor. So let's reference the previous page. I'm given a growth rate, so I'm going to follow this top section here. So I'm going to take my growth rate, I'm going to change it to a decimal and add 1. So 6% as a decimal. Please do not write 0.6, otherwise I will freak out. So that is 0.06. So I change that first, and then I add 1. So now I have this number 1.06. And this right here, my friends, is my growth factor. So 1.06 is my growth factor. Now that you've calculated your growth factor, go ahead, fill in the table, please, write an equation, and then answer the rest of the questions, please. All right, so hopefully you guys pause the video. Let's double check our answers here. So at year 0, our stamp is at 2,500. And we're going to use our growth factor to find our next value. So we're going to multiply that by 1.06, which gives me 2,650 or 2,650. I'm going to do the same thing. I'm going to keep multiplying by 1.06 because that is how much its value is increasing by. So 2,809. I'm going to keep going. 1.06. So that is 2,977.54. Multiply it again. So now I'm at 3,156.1924. And then I multiply that by 1.06 one more time. And you guys might be saying, Mr. RG, this is money we're talking about. You shouldn't have more than 2 numbers behind the decimal. And I would say yes, but I need to figure out, or I need to get the closest approximation I can. So I'm going to save my rounding for the very last part. Okay. So I'm rounding to the nearest hundredth because we are talking about money. So in year 4, we're still at 0.19, okay? And then in year 5, we are at 0.56. Perfect. And there we go. So is this increasing exponentially? Why, yes, it is. I'll say that the value increases or does not increase at a constant rate. Right, we can use the fact that it's not linear to prove that it's exponential for right now, right? I mean, what else could we add to this? We could say each value is increased by a factor of 1.06. Okay, so that works as well. Question number 3, it says write an equation for the value v of Sam's stamp after n years. So v equals value of stamp, so defining our variables here, and n equals the number of years. We're going to use the equation v equals a times b to the n power. in this case, the A, remember, that is your starting value or your initial value, whereas B is your growth factor, So we have both of those pieces of information. We have our initial value and we have our growth factor. So let's just plug them in. So V is equal to 2,500 times our growth factor, which is 1.06, and we're going to put that to the n power. And there is our lovely equation. Now it says, how many years will it take to double the value? So I want to know, when will the value of the stamp be not $2,500, $5,000, right? So here we come to a little bit of a guess and check. At year 5, I know that we're at $3,345.56. So I'm gonna take a wild guess. I'm gonna say, let's try 8. Let's try 8 years. So I'm gonna say 1.06. So showing my work here. Shouldn't write in highlighter. There we go. I'm gonna say when n is equal to 8. So I'm going to do 1.06 to the 8th power, and then multiply that by 2,500. So 1.06 to the 8th power times 2,500, and that's approximately 3,084 and 62 cents. Okay, still too low. Let's try 10. So 2,500 times 1.06 to the 10th power. There we go, and then we multiply by 2,500, and that is approximately 4,477.12. Okay, so not quite. Let's try 12. So 2,500 times 1.06 to the 12th power. 1.06 to the 12th power is that, which I'm not going to read out loud, and then I multiply by 2,500, and I get approximately 5,030.49. So my final answer will be, the value will reach $5,000 somewhere between 11 and 12 years. Oh no, my iPad's dying. Okay, let's keep going. We're almost done here. Now, what I would like you to do, we are going to do question B, except you guys will do this on your own, or actually, you guys will do this in your groups. So, it says, suppose the value of the stamp increased 4% each year instead of 6%. So your growth rate is now 4%. You must change that growth rate into a growth factor. So refer back to your reference pages if you forget how, okay? All right, so pause the video. Go ahead and work through this problem in your groups, please. All right, here we go. Hopefully you guys pause the video. I will post the notes and you guys can check your answers after you've completed this lesson, okay? But I'm not going to go through it because we just went through a bunch of examples. So I'm going to move on to the final page here, page 33. Now what's very cool is there's this thing called the rule of 72, and it's used in investment a lot. So it actually calculates how long it takes for you to double an investment. So if you take the number 72 and divide it by your interest rate, or the actual, is that your growth rate? I believe that's your growth rate. Let me double check really quick. Let's see. Rule of 72, where are you? Yes, I was correct. If you divide 72 by your growth rate, you'll actually get the number of years. So if we do, for example, the last problem, that we just did, we invested, well, okay, the stamp was at 2,500 and we were increasing by 6%. So let's do 72 divided by 6, which is approximately 12 years. And isn't that what we got? Somewhere between 11 and 12 years. So it kind of gives you a nice quick, not exact answer, but a pretty close one. Okay. On this page, we're going to practice finding the growth factor given a growth rate. And then we're also going to practice finding a growth factor given... Wait, I just said that. We're on this page, we're going to find growth factors given a growth rate, and we're going to find growth rates given growth factors. Whew, there we go. All right, so I'm going to walk through a couple of examples for each of these, so that way you guys can practice on your own. Okay, so 0%. Now, if you forget how to do this, that's why I had you guys star these two things. So we're given a growth rate, we need to change it to a decimal and add 1. So that's the first type of problem we're seeing here. So 0% as a decimal, so I change it to a decimal first. So 0.0, and then I add 1, which equals 1.0. That is your growth factor. So for question A, 1.0. 15%. Change it to a decimal, so 0.15. Then you add 1, 1.15, and that is your growth factor. I'll do one more for you. 30%. Change it to a decimal, so 0.3. Add 1, so you get 1.3, and that is your growth factor. Okay, so finish these off, and please, for question number 2, explain in words. Be specific. Don't just say you take this number, you add another number, and you get the thing. Right? Be specific, you guys. These are your notes, right? They're supposed to help you on quizzes and all of that good stuff. So the more specific they are, the better they will help you. All right, a few from question D. Find the growth rate associated with each growth factor. So if you are given a growth rate, you need to change it to a percentage as per our reference page, and then you're going to subtract 100%. So 150% minus 100% is 50, and that right there is your growth rate. So one more. Change the decimal to a percentage, so that's 125%. Okay, subtract 100%, and you're left with your growth rate. So your growth rate is 25%. Okay, go ahead and finish this off, and then write again, be specific please. How can you find the growth rate if you know the growth factor? All right, you guys, that's it for this lesson.